Good everyone, my name is Graphics. Today we'll be looking at another topic under electrical engineering science, which is superposition theorem. And the theorem states that in any linear network containing more than one source, that is more than one source, the current in each voltage across any branch can be found by considering each source separately and adding their effect. So if we want to find the current in each voltage across any branch, we need to short circuit any one or two of the source. We'll just leave one and we'll short circuit the other one. So now let's start by analyzing this. Now, short circuit the 24 volts source, and we'll be having this. Now, this is what we have. If you notice, I have short circuit the 24 volt source. That means I have replaced it with a wire. Removing an element, replace with a wire. Now, if you notice, I'll now be considering the 30 volts source. So if you notice it here, we'll start looking for the total current here. So using your series and parallel knowledge, we know that these two resistors here are in parallel, right? Because there's a split of current at this junction here. So we'll say that we represent RA equals to R3 parallel to what? R2. That again? So this simply means RA is equals to what? R3 R2 all over R3 plus R2. If you have been following my video, you get to understand how this come about when resistors are in parallel. So from here, RA will now give me R3 is what? 3 multiplied by R2, which is what? 2 all over what? 3 plus 2, and we're going to be having 6 all over 5, which will be 1. We have 6 divided by 5, 1.2 ohms. So I'm going to redraw, putting this together, and I'll have something like this. So we'll be having this, right? Now, since I've solved these two in parallel, they are now 1. So both of them in parallel are now in series with this, because this circuit is not sharing any current. So it's I1 that is flowing through everything here. So I will now have these two are in series. So I'm going to be having my R equivalent will be equals to R1 plus what? RA. So which will now give me, what is the R1? R1 is 4 plus RA is 1.2, and that will give me what? 5.2 ohms. That is our R equivalent, right? So now we've done this, we need to calculate for the total current. So according to Ohm's law, it says that what? V from here, V is equals to what? IR, right? So our I will be equals to what? V over R. So the I we're talking about here will be this I1, which is also equals to what? Our I total, and that will be equals to V over R. What is the total voltage here? Is 30 that we're considering, right? This is 30 here, 30 volts, and that will be 30 over the total resistance we just calculated, and that will be 5.2. So 30 divided by 5.2, 30 divided by 5.2, and that will give me 5.77. So we have my I1 or my I total equals to what? 5.77 amperes. So this is what My I total is here, right? So we'll call it I. It will be I prime, right? Total. So we're moving forward, because when you short circuit, we'll call them prime, prime, prime. So let's proceed. Now after we've done that, we've gotten this, we will now short circuit. We will now look for the current flowing through R2 and the current flowing through R3. So how we going to do that? So we use current divider rule. So using current divider rule, we'll be having this. From here, just look at the logic here. This is RA. I want to look for I2, right? So my I2, I'll put prime. So the I2, I removed this RA, I placed I2, and the question you ask yourself, where is I2 flowing through? I2 is flowing through R2, so I'm going to remove R2. So I'll only be left with what? So we're left with what? R3 times, so the R2 that is passing through, you remove it and you replace it by what? I total. So that will be I total prime. That is this guy here, right? The I total here. And everything all divided by R3, which is 3. So R3 plus R2. This is what we're having here. So if we put in our value, R3 is 3 multiplied by I total, which is 5.77, all over what? 3 plus 2. So from here, this will now give us 3 times 5.77. That will give me 17.30. So we're having 17.31 all over 5. So if we move forward, divided by 5, we're having 3.462 amperes, right? So we'll look for the next one also, the current flowing through the R3 holes. So in doing that, we'll be having something like this. So we're going to replace this RA by I3, since you're looking for I3. So it will be I3 prime equals to I3 is flowing through R3. So I'm going to remove the R3 resistor and place it with I total prime times R2 all over what? R3 plus R2. So this will now give us our I total prime is 5.77A times R2, which is 2 ohms, all over 3 plus 2. So the I3 prime will now be 5.77 times 2, 11.54 all over 5. And this will now give us I3 prime will now give us divided by 5, 2.308. We have 2.308 amperes. So that's what we're having for I3 prime. So after doing for I3 and I2 prime, so the next thing we'll do, we're going to short circuit the 30 ohms, the 30 volt source. We short circuit this and we'll use the 24 volts. So that will be our next target. Now we'll short circuit the 24 volt source, the 30 volt source. And using you recall that the current will now start flowing in this direction. So we're having the same I3, we're having the same I2, and we're having the same I1, right? So if you look at it very well, these two resistors are in parallel because there is a split of current at this junction here. So you write that RA is equals to what? R1 parallel to what? R2, and that will be RA equals to what? R1 R2 all over R1 plus R2. So, and this will give us R1 is giving us 4 ohms times R2 is giving us what? 2 ohms all over 4 plus 2. So this will be equals to 8 all over 6, and 8 divided by 6 will be, so my RA will be equals to, so it will be 1.33 ohms. Now we will draw this to see what is happening, since these are now taken as one. Now we'll be having this. Now we still have, now the RA and the RO3 are now in series. So when you solve that, we'll be having our R equivalent to be equals to RA plus what? RO3, and this will give me 1.33 plus 3. So that will be what? 4.33 ohms. That's my R equivalent. So that's our equivalent here. Now from here, we'll use recall calculating for current. Calculating for current. We know very well that a V is equals to what? IR. That is what? Ohm's law. So I will now be equal to what? V over R. Now there's one thing you need to know: how to differentiate the first circuit from the second circuit. Now the second circuit will now be prime prime, prime prime, prime prime, right? So in this case, we'll be having, this will be the V total, which is 24, all over the R equivalent, which is 24 over 4.33. So my I3, which is the same thing as the I total, prime prime, so I3 prime. Because if you look at this, look at our circuit very well here, the current that this 4 volts is producing is I3 prime prime. So and that is the I total of that circuit. So from here we move forward, so that will be I prime prime, so equals to 24 divided by 4.33. So we have 24 divided by 4.33, and that will be 5.54. So we have 5.54 ampere. So this is the I total given here. Now since we've done that, the next thing is we want to calculate calculating for I1 prime prime and I2 prime prime. So I want to look for the, using current divider rule, we want to look for I1 prime prime going through here and I2 prime prime. So using our current divider rule to calculate that. So from here, the I1 prime prime using current divider rule, you're going to replace RA from here. You're going to replace RA with the current you're looking for. Since we are looking for I1 prime prime, so you remove this I1 prime prime and replace it with, so I'll have the I1 prime prime equals to, now the question is, where is it flowing through? I1 is flowing through R1, right? So we are going to remove the R1 resistor. So I'm going to remove this R1 resistor and I replace it with what? My I total. So I'll have my I total prime prime, which is this, multiplied by what? The R2 all over R1 plus R2. So everything remains intact except that R1 I removed. Look at it very well. Everything remains intact except the R1 I removed due to the fact that I1 prime prime is flowing through. So if we put all our value here, we're going to be having our I total here will give me 5.54 times R2, which is 2 ohms, all over, we have 4 plus 2, so we are going to be having this, so 5.54 times 2, 11.09, we have 11.09 divided by 6, so my I1 prime prime will now give me 11.09 divided by 6, and that will be 1.847 ampere, right? That's amperes. So that's our current I1 prime prime. Now we're going to do the same thing. We want to look for I2 prime prime. So if I write for I2 prime prime, so for I2 prime prime, I'll be having, if you look at this, I2 here is flowing through R2, so I'm going to remove only R2 from here and everything remain intact. So to be R1 times I total, so we're going to be having R1 times I total prime prime all over R1 plus R2. So this will now give me the R1 given to be 4 times I total, which is 5.54 all over 4 plus 2. So this will be 5.54 times, we have 5.54 times 4, that is 22.16, we have 22.16 all over 6. So the I2 prime prime will now be equals to 22.16 divided by 6, that's 3.693. We have 3.693 ampere. So that's what we're having here. Now we've gotten our total current, so let's write all the current we've gotten. We've gotten for our circuit here. All the current we've gotten here is, we have I1 prime, we have I2 prime, we have I3 prime. We also have I1 prime prime, I2 prime prime, and I3 prime prime. So what is I2 prime prime? I2 prime prime is given as a 3.693. So we'll go down, I'll fill it here. We have 3.693 amperes. Then I1 prime prime is 1.847 amp. So I3, which is saying the I total, is given to be 5.54 amperes, right? That is the I3. So I3 is just that I total is this. This is I1 prime here. So move forward. So from here, solving that, the next thing we'll be looking for will be our I1 prime. So if you look at what we've done before, I1 prime is given to be this. I1 prime is this. What we calculated before. We have I1 prime, which is actually I total prime, and that will be what? 30 over 5. That will be what? 5.77. So we have 5.77 amperes. Then the I2 is given to be 3.462. So I2 is given to be 3.462, and I3 is given to be 2.308 amperes. They're all in amperes, right? So that is the I3 here. So the next thing we'll be doing here is that if we want to know what the current flowing through the R2 ohms, right? We want to know the current flowing through the R2 ohms. So this ohms here, we want to know the current flowing through this R2 ohms here. So what we'll do is I2 is facing down. So my I2 will now be equals to, you see that I2 prime is facing down, and I1 prime also is I2 prime also is facing down. So it will be I1 prime plus what? I2 prime. So the current flowing through the R2 ohms will be 5.77 plus I2 5.77. Sorry, here will be I2, right? I2 prime, so it will be 3.462. So let me remove this. So my I2 will be equals to what? 3.462 plus I2 prime is what? 3.693. So the current I2 will now be equals to 7.155. That is the current that is flowing through the R2 ohms. So this is the current flowing through R2 resistor. So that's what we have in there. So that will be the current that is flowing through the R2 hoops, 7.155 amperes. So thanks for watching. We'll meet in our next video. Don't forget to click on the subscribe button.